Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to the channel, leave a like, comment. And so in today's lesson, we are continuing with combinations and permutations. You can check out our previous lessons on what we covered. But in today's lesson, we're going to work out these problems that are here. Then I will see how we go on from there. So hopefully you'll be able to do other problems as we work on these problems that are here. So this problem is actually from the tutorial sheet for those that we are learning with online. So yeah, let's dive into the first question. The first question reads, in how many ways can a 5-digit number that ends with a 0 be made using the numbers 0, 1, 2, 3, 4? Okay, so first of all, we need a 5-digit number. So we need 5 slots, 1, 2, 3, 4, 5. Okay, so we need 5 slots for that 5-digit number. Then we've been given the condition that that number should end with a 0. So we should have a 0 at the end here. Okay, so now let me just zoom in. Okay, hope you're able to see. Let me just do a bit of okay, like that. Okay, so we should have a 0 at the end. So we'll be looking at the possible combinations that we can have in these spaces. So if we have a 0 at the end, how many possible zeros can we have? We can only have one number here, so we can only have one possible combination here, which is just a 0, which is one possible combination. Then for this question, we're also considering the fact that we've been allowed to repeat, because if they didn't allow us to repeat the numbers, we would have used another approach. So but for this one, we've been allowed to repeat the numbers. So considering that we've been allowed to repeat the numbers, for this slot we can either have a 0, a 1, a 2, a 3, or a 4, because we can repeat the 0 here. So the 0 can come again here. And for this slot, we can have 1, 2, 3, 4, 5 possible numbers there. Okay. Then again, considering that we are allowed to repeat the numbers again. So for this slot, again, we can have either a 0, a 1, a 2, a 3, or a 4. So again, here we would have 5 possible combinations that we can have there. Again, here we are allowed to repeat the numbers. We can have a 0, 1, 2, 3, or a 4. Again, that is 5 possible combinations for this slot. But here we can only have a 1, 2, 3, and a 4, because there is no 5-digit number with or 5 spaces that can begin with a 0. Or in other words, we're not considering numbers. Do we count numbers with 0? Let's say 0, 2, 0, 1. No. So this 5-digit number cannot begin with a 0. It can only begin with a 1, a 2, a 3, or a 4. So for the first place here, we only have 4 possible combinations. Okay. So now what we do here is we're going to multiply out. So 4 times 5 times 5 times 5 times 1, which will give us 500. Okay, so how many 5-digit numbers can be made for this? So that is 500 possible combinations. So that is 500. So that is the answer for this question. Now let's look at let's try to modify the question. Suppose they said we cannot repeat the numbers. Okay, so suppose they said we cannot repeat the numbers. So let me just suppose repetition not allowed. Okay, so if repetition was not allowed, again, we would have 5 slots, 1, 2, 3, 4, 5. So again, we're considering that the 0 should be at the end. So that is the 0 will be at the end. So for the last position, we can only have one possible combination. So now from this, we've ruled out a 0. Okay, we've ruled out a 0. So we can only have either of these four possible combinations. For this slot, we can have a 1, a 2, a 3, or a 4. So for this slot, we can only have four possible combinations. Then for this slot, we can, so for if we remove one number from here, it can either be a 4, a 3, or 2, or 1, would remain with three numbers. So here we can only have three possible combinations here. So we don't know, it can either be a 1, a 2, a 3, which remains here, would remain with three possible combinations here, which is 3. Then here, if we remove one number, which has remained here, and we don't have to repeat it here, we can only remain with two possible combinations. So that is, repetition is not allowed. Then here, when one remains, either a 1, a 2, so here we have 2. Here we can have only one possible number that can be there. So from the 4 here. So we cannot begin with a 0 here. So we just multiply that. So these are not zeros, they are just possible numbers that we can have from the 4 here. So if we had 4 here, so from these 4, we can leave 1 here, then we would remain with 3 possible numbers that we can put here. If we leave 1 here, we can have 2 possible numbers that we can put here. And we leave 1 here, we can have 1 possible number that we can put here. So now multiplying this out, 1 times 2 times 3 times 4, that is 24. 1 times 2 times 3 times 4, that will be 24. So that is if repetition is not allowed. Okay, so now let's consider another iteration of the question. So suppose, I'm going to do this. So suppose they just said, how many, let me use this color here. So suppose they said, how many 5-digit numbers, if they didn't say ending with 0 here. Okay, so they just said, let me remove this. They just said how many 5-digit numbers can be made using the digits 0, 1, 2, 3, 4. So again, we're considering that repetition is allowed. So if rep is allowed, repetition is allowed. If repetition is allowed, then we would have 5 slots, 1, 2, 3, 4, 5. Then how many 5-digit numbers can be made from this number? So we would consider the fact that on the last space here, we can have a 0, 1, 2, 3, or a 4. So we would have 5 possible numbers here, 1, 2, 3, 4. Then here, repetition is allowed. Again, we can have 0, 1, 2, 3, 4. So that is 5 possible numbers. Again, here, repetition is allowed. So we can have 0, 1, 2, 3, 4. That is 5 possible numbers. Here again, 0 is 1, 2, 3, 4. So again, 5. But here we cannot begin with a 0 because no number begins with a 0 in counting. So this would only leave us with either a 1, 2, 3, or a 4. So this is 4 possible combinations. So we multiply out the possible combinations. So that is approximately, it's 2,500. I'm not mistaken. Let me just check that. Okay, so for the same question, we can also look at how many 5-digit numbers can be made using the digit like this. Now, if repetition is not allowed, repetition is not allowed. Okay, so if repetition is not allowed, we need 5 slots, 1, 2, 3, 4, 5. So how many 5s can be made using the digits 0, 1, 2, 3, 4 if repetition is not allowed? So for the first slot, we can only have either of the 4 numbers. We can have a 1, 2, 3, or a 4. So for the first slot, we can have either of the 4 numbers, 1, 2, 3, or 4, because we cannot have a number that starts with 0. So we can have 4 possible numbers. Okay. Now for the second slot, we can have either 0, 1, 2, 3. if 4 was put on the first spot, or we can have 0, 1, 2, 4 if 3 was put on the first slot. So we can only have 4 numbers here. So I'll just put circles here. So we can have 4 numbers from the 5, which is, I'll put circles like that. We can only have 4 numbers if repetition is not allowed. So suppose 0 is not taken, so we can have a 0, a 2, 3, 4, or we can have a 0, a 1, 3, 4, 0, 1, 2, 3. So we can have 4 possible numbers here. So again, we can put 4 here. Then from the 4 here would have 3 possible numbers, 0 like that. Since repetition is not allowed, so 3 possible numbers. So again, from the 3, if 1 remains here, we can only have 2 possible numbers. Again, from the 2, if 1 remains here, we can only have 1 possible number here. So that is basically your approach here. So for the first slot, we cannot begin with a 0, but for the second slot, we can have a 0, 1. So considering that either of these numbers were put here, we would only have 4 possible numbers from this. We can have a 0, 1, 3, 4, or 0, 3, 4, 2, or 0, 1, 2, any of the 4 possible combinations, considering that either of the 1 was left here. So then from the 1, if we leave 1 here, we're going to have 3 possible numbers. If we leave 1 here, we're going to have 2 possible numbers, and so on and so forth. So we multiply that. So let's multiply out these numbers. So that will be 4 times 4 times 3 times 2 times 1. So what we get is 96. So this gives us 96 possible ways of putting numbers such that repetition is not allowed. So yeah, so basically that's about it. Let's move in on the next question. Yeah, so hope you've written all those questions that we made from question 1 so that you'll be able to go